calculator, and you can use the Desmos calculator that they give you on the test. But I'll try to show you the Desmos calculator. I'm going to get it for today. That'll be an easy way to see it. So basically what they did is they have given us, let me check this out. Basically they gave us 30 questions. There's 30, these are called release items. That means that these 30 questions were supposed to be on the, these are things that, topics that they are going to use on the exam for Math 3. And some of these are hard. These are hard topics and hard questions. And the exam in general is difficult, and that's in a normal year. Okay? So, especially this year, it'll be increasingly difficult. So that's fine. It's not something to be scared about. But it is curved, so you can get some points added to your score. Hello. Yeah, I'm doing a review session down there. That's fine. I was just making sure I get Miss Brown has all my rosters. And the coach for East Lincoln said I need to have 4 boys and 4 girls in order to have an official team. So yeah, I do. That's what I'm saying. So I think we're fine. Yes, and I've got copies of it I need to give to you. Yes, sir. Yep. Yes, sir. All right, bye. Okay, so there are, again, I went through all that. So when we're going through, it's curved, the exam's curved, so there will be questions. You will get extra points, obviously. In general, I was trying to look back and see if I had any of my last ones, but I can't remember right offhand. But in general, the curve, okay. So just to give you an example, but in general, I'll give you an example. A student had 37 questions on this, and they got 19 out of 37, which was just over half. And it was a low B, but they got a B. A B, not a D, a B. So in this one, on the Math 3, there are, it's not always that drastic, but it's usually if you're shooting for half, if you get at least half, you're doing pretty well. They like you answer. Same thing with AP exams. So if you're taking AP exam, if you get at least half the questions correct, you're going to make it a level 3 on the AP exam. But when you're looking at these questions, you're looking for to try to get at least half right. Now, a lot of times, though, on the exam questions, you are going to see the answer that maybe you worked out, but it's the wrong answer. So when they're working through the 4 answer choices, they're trying to give you all the ways that you would work the problem incorrectly. So when you work the problem incorrectly, you may see your answer choice sitting there, and when you see your answer choice sitting there, you circle it, but that does not necessarily mean that you got it right, okay? So you need to make sure that you are looking through and checking your work and going through. You use Desmos to help you, especially on ones that you don't know. If there's one you don't know, then we just go to the calculator, try to plug some stuff in like you've done before, and then go get that answer. Don't sit on that problem. Now, but the other thing is, you actually have to be in there. You're stuck in a room. Only 12 people will be in your room where you're testing. So you may be testing in here. You may be testing beside me. You'll be testing somewhere on this hall, usually on Thursday. But you're stuck in there from 8 to 12, okay? So if you finish in 15 minutes, then you just sit there for 3 hours and 45 minutes. So in my opinion, I would just sit there and take my time and not rush through it. And I got to be there for 4 hours anyway, and just go and take my time on it. If you think about it, in a normal semester, the semester is 90 days, and this is going to count 20% of your grade. So 20% of 90 days is, does anybody know how many days that is? I know, but I was just, since we're in a math class, I thought I might ask. Huh? 20% of 90 days. Yeah, 18. So 18 days. So the exam counts as 18 days of class. So when you're sitting the exam and you think, oh, this is a long exam, it's 4 hours. Well, it's actually counting on your grade as 18 days of class. So it's counting as almost 4 weeks. Yes, you should think about that with any exam that you take. I always tell my students to think about that with any exam you take, that, hey, it's counting 20% of your grade. It's 18 days of the class out of the 90. And we're really not even in there 90. We're in there maybe 80 or something like that. Okay? So those are my tips for you. Use your calculator. Use a Desmos calculator. Try to work the problems. There's going to be some you don't know. There's 60 questions, but only 50 count, so you don't know which ones don't. So make yourself feel better if you find one that doesn't count or that you don't know. Just act like it doesn't count, and you never know. You'll never know anyway. And then there's 2 strategies. You can do either one you want. I prefer the second one, but I'll give you the first one too. Obviously, the first strategy is you go in order, just from 1 through 60, and then you answer a question the best you can. Then you go back to the ones that you didn't know. The second strategy that a lot of AP teachers like to do too, and it's pretty successful, is that you start the exam at 8 a.m. and you're kind of a little bit nervous maybe or whatever, or wanting to get it over with, anxious, whatever. And you go and you can scroll through. Just because you skip a question on that thing doesn't mean anything. It'll tell you that you haven't answered it before you submit. So you just scroll through and you find 1 or 10 or whatever that you know you can do. Like one might just be, there's a couple on here we'll see that's just like graphing, or add these numbers together, or subtract these 2 numbers, or whatever. And you pick those, you go ahead and answer those first and get your confidence up a little bit and go to the easiest ones. And there's no prize for answering number 1, 2, 3, 4 to 60 in order. And there's no penalty for answering number 60 first. A lot of times when people try to go in order, they get through like maybe 20, and then they realize that they don't really know anything. And so then they just say, I'm just going to guess on the last 40. Well, the last 10 might have been the easiest questions on the exam. So that kind of hurts them. So I've seen it hurt people a lot when they go in order, but you can do whatever you want. That's just an exam tip in general. So again, you want to use your calculator, you want to use a Desmos calculator. I'll show you the Desmos calculator on here in a little bit. So let's look at the first couple questions. We will look over 1 through 20, or 1 through 30, I think there is. We will look over those questions and then kind of show you how I would work them and what's the best way to get the answer, how can we use the calculator on it, etc., and then we'll go from there. Okay, but remember, tomorrow and Wednesday you're off, and then Thursday at 8 a.m. is the Math III EOC. It starts at 8, okay? So I would get to school like a normal time, 7:45. Because at 8, that's when they want to shut the door and get it started. So if you show up to school at 8, there's a chance they get it started, and then you got to come back again another day. And the longer you wait to take it, the worse it's going to be, in my previous experience with this. Okay? All right, so notice. Another thing you'll notice on Math 3 and Math 1, because it's an EOC, because it's a state exam, is that not every question is multiple choice. Okay, so you start to say, oh God. But not every question is multiple choice, meaning that some of these questions are what they call gridded response. That means they give you a little text box about that big and you type it in. Or fill in the blank, or you'll see some of these are dragging, where you drag one thing across and to your answers and match them up. So number 1 says, what is the remainder when x to the third minus 1 is divided by x plus 2? So you only have to know, really have to know like one thing here, and you should see one of these problems. I've gone through, I've made a list of all the topics that are on this exam. This is my list of all the topics I thought you needed to know for the exam. So, Frontier. Yeah, because I'm full in here, I'm sorry. So, this is my, let me show you. There's a couple people on here. Let me show them my paper. This is my list of all the things I thought you needed to know for the exam. And I recorded this so you could have it. You can get through all the stuff and go to the questions. But one of the things that I definitely thought that you had to know for the exam was what's called, we called it the remainder theorem. And we did it in the polynomials unit. And that's what this question number 1 is. It's basically just plugging in the number. So x plus 2, when you divide by x plus 2, it's really x plus 2 equals 0. So you're really dividing by what? Anybody? Negative 2, right? It's always the opposite. So it's really x equals negative 2. Now, if x equals negative 2, all we have to do to find the remainder theorem says if you know what you're dividing by, the only thing you have to do is plug that number in for x. Okay? So all we have to do is say negative 2 to the third power minus 1 equals. And that is our remainder. Okay? Some people wanted to go and do like synthetic division. There's another time and a place for that. Later on, but not here. Here it's just we're trying to find, if it says what is the remainder, you're trying to take the number you're dividing by and plug in the remainder. And the answer to this would be what? If you do on your calculator. Anybody? I'll wait. I'm scared. What is it? Negative 9. Good. Okay, now, the most common mistake here is, anybody give me the most common wrong answer on this one? There's an answer choice that is the most commonly picked wrong answer. I like to know what people do wrong sometimes. If you know how to do it right, it helps, but it also helps to know what. No. The answer. I'm looking for what answer is that's wrong. What's there? The answer is negative 9. No. That's a good. Oh, because negative 2 to the third is negative 8. There's another one. It's the most commonly picked wrong answer on this. Negative 9 is right. Negative 10, sorry. Most commonly selected wrong answer here. 7. 7. How would you get 7? Yeah. If you took, a lot of people see a positive 2, go plug it in. 2 to the third minus 1, 7. Answer 7. Right? And so on. So you got to know anytime something's in parentheses, we talked about that all year. That anytime something's in parentheses, what are we going to do? We're going to set it equal to 0. It's the opposite of it that we plug in. So we plug it in. Okay? So just be careful there. There's a problem on the exam with that. That's something like that. I mean, they're not going to put it on their release and say there's not a question. Okay? So if you get one, you'll get one like that somewhere. And your goal is to just plug it in and solve. So that would be negative 9. That's question 1. All right. go to question 2. The function below has zeros, has x minus 7 and x plus 4I as factors. Factors means that's where it crosses the x-axis. Okay, you might want to write that just so you know. I'm gonna give you an example. A factor is the same thing as a root, which is the same thing as a zero, which is the same thing as a solution. Okay, which is the same thing as an x-intercept, which is where it crosses the x-axis. They love to use all different vocabulary. So they like to say, what is the factors? What are the roots? What are the zeros? What are the solutions? What are the x-intercepts? They like to say all of those. But they all mean the same thing. So what I'm going to do here, if I want to find the total number of real zeros. So real zeros means where they cross the x-axis. Now, so 4x plus 4I, you see I means imaginary. That means it wouldn't cross the x-axis, so it's not a real zero. But to find how many times it crosses the x-axis, what would be the best way to do that? Desmos and graphics. Okay, so let's see if I can do this for you real quick. There it is. So if you ever want to simulate what the test looks like, you type in NC State, NC Test. Okay? So here's the test. This is what it looks like on your Chromebook when you're ready to take it, right? You'll hit NC Test, you'll hit log in, then they'll have to log you in and all that good stuff. Okay? I'm restricted right now, but we go to the release items. And it shows you exactly what it's going to look like. That way, when you're practicing it, you realize, okay, this is what it's going to look like, right? So I'm going to skip through these review questions. All right, so now, it tells you can use a calculator for the whole thing. So that first problem we did, you would have to type in -9, and then you would go to the next question. All right, so we get to this one. This is another gridded response. Okay, it says only numbers are allowed in your answer, and you have to write them as a decimal or whatever. So the total number of real zeros. It doesn't say what they are. It says how many are there. What's the total number of real zeros? So we hit Desmos, our calculator. All right, and we can go over and we can plug it in. Y equals 2x to the 5th minus 13x to the 4th plus 22x to the 3rd minus 187x squared minus 160x plus 336. You don't know how many people, I talked to a lot of people in some different counties too that I was doing this with. You'd be surprised how many people told me that this, they thought just meant you could use the calculator. They didn't know you could actually click on it. How nice would it have been to know that's actually your Desmos calculator? So for years, that's been there on every math exam. So you just click on it, okay? Now, it doesn't look good, it's little, but it gives you the ability to make it as big as you would like for it to be. Okay, so you just drag the edges. You can make it as big as you like, you can zoom out as much as you like. I see it crosses at -1.5, at 1, and at 7. So how many real zeros does it have? 3. That's 3 real zeros. That is your answer. Okay. Now, notice, you see where I can, if I'm not sure if I type something in right, I want to show you this. If I click the blue at the top and move it around, you see how it makes it like transparent so I can still see the problem? Yes. Right? So I can still see a problem. So if I'm like typing in the equation, I can type in, I can still see the problem. Now, if I click the X on there and then click the calculator again, guess what? It's gone. Yeah. You can't get it back. So, okay. Try to get it back, can't get it back. So once you hit the X button, it's gone. So what I would ask for you to do is hit this. That way you can see what you're doing, and maybe even make it smaller again, whatever. But then once you've got your answer, you can type it in. Now, the good thing that it does do is for the next problem, it will already make it as big as you had it. So it keeps you at the settings that you had it at. Remember on the little wrench thing, it is actually set up for degrees, which is what we usually use, is degrees. So if you're putting in like sine, cosine, tangent, we simply use degrees of the triangle. So it's actually already set up for that. But if you have to change it, it's on there. We'll talk about that. Alright. So we got the next question. It says, the graph of the function has a 0 at -1. What are the other zeros of the function? So this graph is x to the third plus 3x squared minus 2x minus 4. It has a 0 at -1. What are the other zeros of the function? So a 0 at -1 means what? If it has a 0 at -1, what does that mean? Yeah, it crosses the x-axis at -1. So where else does it cross the x-axis? That is the question. Okay? So, we look at where else does it cross the x-axis. Let's graph. So again, if you were at home doing this, all you gotta do is Google NC State, NC Test, and you can do it. So I'm gonna say y equals, and again, if I'm not sure what it is, I'll make it transparent. X to the third plus 3x squared minus 2x minus 4. Alright, so one of the zeros was, it told us was -1. That's this one. Here's the other two. -3.236 and 1.236. Okay? Now, that means, let me make this a little bit smaller. That means that answer choice A, because if I click these, you see what they are. Answer choice A and answer choice B are definitely incorrect. Correct? Those are wrong. I like doing that too. It's kind of just eliminating. Correct? So A and B are wrong because it's decimals for them. So the way to find out which one's right is to just type it in the calculator. So I'm going to say -1 plus the square root of 5 and -1 minus the square root of 5. Notice, those are your two answers, right? So that's your answer. -1 plus or minus the square root of 5. If that wouldn't have worked, we would have went in and typed 1 plus 2 square root of 3 and 1 minus 2 square root of 3. And it should have given us our two answers. So the decimals should match that. So like these first three problems that I'm just showing you, these would be three that if you found them on the exam, the first one you just use the remainder and you just plug the number in. The next two, we've just been graphing them, looking at where it crosses the x-axis. These would be three that I would want to make sure I got early on and built my confidence, and I was doing very well. Okay, good. All right, so that is question number 3. If you have questions as we're going through, you just stop me and we'll keep going. When we get through 10, we're going to take a little break every 10. Okay, because I can't do 30 in a row. This says, which expression is equivalent to x squared minus 2x minus 37 divided by x squared minus 3x minus 40. And I have an answer for that. But what we're wanting to do here in these problems is we're trying to see which of the, all we're trying to see is which of those four is the exact same thing as the given problem. Okay? So, there is a way to do it. It really kind of scares me to tell you. There's So I'm going to give you kind of again, 4 hours on the exam. So there is time to do this as long as you take the necessary. And one question could be 5 points on 20% of your grade, which you can do the math there. But what I would do is take the original problem, and the original problem is x squared minus 2x minus 37 divided by x squared minus 3x minus 40. What I also would do is watch me go back over these when you're at home, like, what's today, Monday, like Wednesday, okay, when you're bored, which you have Wednesday. So on Wednesday, I would watch this again. And you can fast forward on my phone and just see what you do and look at the problems and kind of make sure you remember. Because it is proven that if you go through these again, not cramming it, it's proven that if you stay up all night and cram, that you do worse. But it's also proven that if you just go through it regularly, like the day before, that when you see a problem like that, your brain a lot of times will make that connection. Okay? So x squared minus 2x minus 37 divided by x squared minus 3x minus 40. We want to see which one's equivalent. If it's equivalent, what should happen? Yeah, they're just going to go right over each other, right? So 1 plus, let's do x plus 3 divided by, and you got to put in parentheses or it won't do the right division, x squared minus 3x minus 40. We got lucky, right? That one matched up perfectly. So that means that's the answer, right? Now, what if I'm just what if that just randomly happened and it's wrong? Let me try B. Let me just do 1 minus. All I got to do is change it to 1 minus, right? You see how that didn't match up? Everybody see? Okay. But for 1 plus, you see how it matched up? And if you ever want to see if it matched up, all you got to do is click over here. It takes the line away and it puts it back. See how I just took right over? So that means it's equivalent. So A is equivalent. I don't know if you like that method better or not, but the other method is using long division, which is not the best way. It's like when you have the calculator as a resource, I would use it, right? That way you don't have to remember so many formulas. Long division would be another formula you'd have to remember to try to get. So that's number 4. Does anybody have a question on how I did that? Does anybody see the percentage? You can go through and see. You realize I've used decimals for 3 and 4 right now? It's there. I'm not saying that you can pass with it, but you can pass with it. Number 5. Okay, number 5 says, ooh, nice. Number 5 says, place, so click and drag into the appropriate boxes the values of A, B, and C that will make the equation shown below true. Now in this one, I actually, honestly, would work the problem out. You can, it's not hard. We can do it. We've done it before. If you can do the box method, you can do this problem. Okay? And the box method is for math 1, so I think you can do it. Alright, so these are something that we did in, I want to say unit 7 is rationals, I think. Rationals was unit 7. We have denominators, 4x plus 3, and we have 7x minus 2. Those are our denominators. Now, common denominators mean, you see, this is going to be my least common denominator, both of them together. So they don't have anything in common. So that means this one is missing the 4x plus 3, and this one is missing the 7x minus 2. So we're going to multiply 3x minus 5 by what it's missing. It's missing 7x minus 2. And then we're going to say plus, and then we're going to multiply the negative 2x plus 1 by what it's missing, which is the 4x plus 3. Okay. Now, we've got to do the box method twice and then simplify. So that, there is a little bit more, but it's something that this is again like one that's very doable. You can still do well, okay, with this. Alright, so let's take the box. We've got 3x minus 5. We've got 7x minus 2. So we've got 21x squared. I'm going to multiply negative 5 times 7x, that's negative 35x. 3x times negative 2 is negative 6x, and negative 5 times negative 2 is 10. over here, you're going to do negative 2x plus 1 and 4x and a plus 3. So negative 2x and 4x is negative 8x squared. 4x and 1 is 4x. Negative 2x and 3 is negative 6x. And 3 and 1 is 3. Anybody have a question on how I'm doing the box? I think that's fairly simple. Good. Remember the diagonal of the box is what you add together. So we're going to combine these together. So we're going to get 21x squared minus 41x plus 10 plus negative 8x squared minus 2x is negative 6 and 4 plus 3. Okay? I want to add those two together. So take a minute and try to add those two together. You just want to combine like terms. Combine the x squares, combine the x's, and then combine the numbers. So you want to combine the x squares. Combine the x squares, combine the x's, and then combine the numbers. Okay, so from that, I had I had 21x squared and negative 8x squared. Okay, so negative 21x squared and negative 8x squared add up to what? 13x squared. So there's our first number. So what you would do, if you were working the exam, you would take that 13 and you would move it right there, right? That's your 8. Okay? Then negative 41x and negative 2x, that would be negative what? 43x. So it would be right there. That's your B. And then 10 and 3 is 13. Now notice what they do, guys. Okay? If you did 10 minus 3, you would get, or if you did 10 and negative 13, you could get negative 7 if they were both negative. If you did 41 and 2, let's see, I don't know what else you could do there. 13, if you did 21 plus 8, you would get 29. You see how that 29 is? So they're finding ways that you might do it incorrectly, and those are some other answer choices. So you got to make sure they're good. So in this problem, I am trying to find the least common denominator. The good news in this problem is they helped me tell what the least common denominator was. It was 4x plus 3 and 7x minus 2. So this fraction was missing 7x minus 2, so we multiplied it by 7x minus 2. This fraction was missing 4x plus 3, so we multiplied it by 4x plus 3. We did the box method, because that's what we needed for both of those, because it's a binomial times a binomial. And then we added them together to get our final answer. Okay? So, was there multiple steps in that problem? Yes. Is it hard? No. Yes.
Can you explain how, or why we multiplied with 3x minus 5 times 7x minus 2?
Yeah, so why you do it is because the denominator that we need is 4x plus 3 and 7x minus 2. This one has 4x plus 3. So it needs 7x minus 2. Now it has the same denominator as this. So you've got to figure out what this is up here. This one has the 7x minus 2, but it needs 4x plus 3 and 7x minus 2.
Oh.
So really, you're actually multiplying it to the top and the bottom. It just doesn't need to be simplified in the bottom because it's not important. That's not what we're looking at. We're looking at the top of the fraction, the numerator. All right? What number was that? 5. So we've used Desmos for 3, and then we have, on the other two, we have had to work out some stuff, but we have the box method for one and the remainder theorem for the other. Okay. I feel pretty confident if you see a type of question on the release that you'll see it on the exam and more. Okay, and I have more, and what I'm going to do is on Wednesday, I'm going to do a brief overview, and I'll email you. You don't have to listen to it, but it can only help you. Okay, so I'm going to go through a brief list of some of these topics. I know it looks like a lot. I wrote down 57 topics that I thought that I know the exam covers because we've worked through all these things that are in our curriculum, and they tell us what's going to be, basically on the exam. So I can I'm going to go through some of the things I think you need to know as quickly as possible. I spend it like 30 seconds on each topic in a video, so I'll send that to you. And that would help you a lot also as you're going through this. All right, number 6. Which expression is equivalent? So let's look at it. First of all, there's a lot of things going on here. The first thing that you notice is you see division. Anytime you see division, we need to do what? Huh? Yeah, switch and multiply. Good. So I'm going to say x squared minus 5x plus 6 to the negative 1 over x minus 2 to the negative 2 times, and I'm going to flip the second fraction, x minus 2 to the negative 2 over x minus 3 to the negative 1. So I'm flipping. Now, I have negative exponents. What happens if we have a negative exponent? It needs to be flipped. It needs to go to the other side. So we're actually flipping again. Anytime you see a negative, the negative exponent's on the bottom, it goes to the top. If the negative's on the top, it goes to the top, and it becomes positive. So there's a lot of flipping. That's the problem in this one. And then x squared minus 5x plus 6, that was to the first power. So do we need to write the 1? No. Okay. Times x minus 3 to the first power, and then we have x minus 2 squared. Okay. Whew. So here's the issue with this problem. It's not hard at all. The issue is, do you know when you divide fractions that you have to flip the second fraction to make it multiplication? Okay. So yes. Do you know that if you have a negative exponent, you have to move it to the other side of the fraction to make it a positive exponent? Yes. And that's all you have to do. But it's because all of them are negative exponents, and we have division. They combine. That's what the exam does sometimes that hurts. It's like they're combining like 2 or 3 different things you need to know all into one problem. All right. Now we can start canceling things out. X minus 2 squared and x minus 2 squared go away because there's one on top and one on bottom. This one is not factored. X minus 5x plus 6. 2 numbers that multiply to give me positive 6 and add to give me negative 5. Negative 3 and negative 2. Negative 3's are gone. So, what's left on top? Yeah, there's nothing there, so we have to put a 1. And on the bottom, the only thing that's left is x minus 2. So there's our answer, D. 1 over x minus 2. And that is number 6. Now, it is possible, I'm going to give you the possibility. I could take that whole big problem, if I did it correctly, I could type it into Desmos. I could then go in and type each answer in until I get one that is equivalent, meaning it goes right over it. Now, I don't know if that's the best way or the quickest way, but if you forget what to do, anytime you see equivalent like that, that's a possibility. So that gives you a second option. It's always good to have 2 options in case the first one, if you lose the first one, then on the second one, you'll be able to hopefully catch up with that. Okay, so let's go to the next question. This will be question number 7. We've been here 45 minutes. That's good. That's not bad. All right, number 7. This is more of a just reading and understanding how the problem's set up. It's an absolute value problem, as you can see by the answer choices. Okay, the problem, we want to write this. This is the important thing to know. There's basically a formula. If you looked way back in your notebook in Unit 1, if you had a notebook, I hope you did, that'd be nice. But if you go back to Unit 1 and you look at this, there's a formula for it. It's at the very end of Unit 1. And it says x minus the ideal is less than or equal to what we call the tolerance. Okay? Now, the ideal is what we want, right? It's our ideal. It's what we would love to have. It's our ideal. The tolerance is how much we will tolerate it being off, like how much error. Like if I say, I want 50 chicken nuggets, that's my ideal. But if McDonald's gives me between 45 and 55, I'll be okay. I'll tolerate it. Right? So my tolerance would be 5 in either direction. Right? So that's what's happening here. So notice, one machine fills each box with approximately 32 ounces of spaghetti. After the boxes are filled, another machine weighs the box. A box is discarded. They get rid of it if the weight of the box differs by more than 0.25 ounces from the target weight. Which inequality can be used to find the range of acceptable weights? So what is our ideal or our target weight? It tells you in the problem.
32 ounces.
Yeah. Okay, so you know your ideal. If you didn't even, you should know your ideal from up here. But if you didn't catch it up here, it actually set it down here, right? So I'm already done, actually. I don't even have to teach the other part because no other problem had x minus 32. No. Now, the tolerance is less than or equal to the tolerance. The tolerance is how far it can be off in one direction or the other, and that is 0.25. Okay? And it says that because if it's more than 0.25, they get rid of it. Now, I'm going to show you real quick what happens. The reason this is true. X minus 32 is less than or equal to 0.25. Okay? If I add 32, I get x is less than or equal to 32.25. And then if I flip it, x minus 32 is greater than or equal to negative 0.25. This was something we did in Unit 1. And if I add 32, x is greater than or equal to 31.75. So it tells me that x is greater than or equal to 31.75, but less than or equal to 32.25, if I actually work that out. That makes sense, because my target's 32, and I can't be more than 0.25 off. So I've got to be somewhere between 31.75 and 32.25 to be acceptable. If it's too far off, it's not acceptable. I got to get rid of it. Okay. So it's always, if you can remember that formula, it is x minus the ideal is less than or equal to the tolerance. That was question number 7. Let's go to number 8. I love number 8 because we're back to graphing. We already did 3 on Desmos, right? 3? I think I said 3. This is going to be 4, so that's going to put us at 50% right now, Desmos. This is number 4. So graph these and tell me, or take a minute and graph these and see which one matches this. If it was me, I wouldn't even have to graph it. I would already know, because I know inside absolute value which way it moves, and outside of absolute value which way it moves. So I don't even need to graph it. But if you need to graph it just to check, it doesn't hurt to check. There's a little trick on this one, though. There's a little trick. You got to look at your numbers. Okay? There's 2 of them that are very, very similar. 2 of them. 2 of these answer choices are very similar. So this is an easy problem, but it gets missed a lot. So I'm giving you a heads up there. Okay, you might get the answer.
B.
It's B, isn't it? It's B. Now, most common picked answer is what? A. Because we're like, dang, some people look at it and they're like, I know that this -2 on the outside moves it down 2, which is good if the slope was 1, right? But the slope is up 2 over 1, up 2 over 1. So the slope is actually 2, which is why it's important to have this 2x. That's your slope. So just make sure you check it very carefully when you're doing Desmos. Does it cross at +1 and -1? If you check that, A would not work, right? But B would. It would cross at -1 and +1. So you that's where you have to be careful, okay? But that equation B matches. They put A there on purpose just because they know you're going to type it in and see that it's down 2 and it looks similar and you just pick it. So you got to be very careful, all right? C, if you subtract inside of absolute value, does anybody know we're inside parentheses, which way it moves the graph? If you subtract, which way does it move the graph? To the right. And if you add inside of the parentheses or inside absolute value, which way does it move the graph? To the left. If you add outside of the absolute value or outside of the parentheses, you're always going up. And if you subtract, you're always going down. So if you remember that, you don't even need your graph, right? But those are just some things that are important to know as you go through. Okay, that was number 8. We've done 4 of 8 using just Desmos. 4 of 8 using just Desmos. This is a work problem, they call. I think this was I'm trying to think where I saw this just recently. Maybe on one of your assignments, but I'm not sure. But it's on the exam, 100%. Okay, I can pretty much say that about all of these. But this is, I remember a work problem many times as we work through the exam, seeing these because they make this an important concept. Basically, a work problem is saying somebody can do it in this long and somebody else can do it in this long. How long if they work together? Now, anybody know what the most common answer is for this one? 3. That's 1. You got the second most common wrong answer. 4 is the first most common wrong answer. They think, hey, if Martha can do it in 2 hours and Jamie can do it in 6 hours, they can do it together in 4 hours, right? Not necessarily. All right, so here's how this will work out. So Martha can paint a room in 2 hours, and then Jamie can take that same room and paint it in 6 hours. So we want to look at how long will it take them to paint the room together. All right, so I use the letter T, time, over plus time over equals 1. You'll understand what it means in a minute. All right. So we're trying to find the time it takes them to complete a job. So it always, when you do one of these problems, when you see one of these problems, it always equals 1. Because 1 stands for the whole job. 1, right? Like 100%, if you're thinking about it. Now, it takes Martha 2 hours. So her time, it takes 2. So you put a 2 on the bottom. Okay? Jamie's time, it takes 6. So you put a 6 on the bottom. Now I'm trying to solve for T. Okay? Anybody know how I could get those? How could I get those numbers off the bottom? It's not really hard. If you have a number on the bottom, let's just say in general, if I've got a problem and I've got a number on the bottom, how do I get rid of it? I multiply, right? So like if I have x over 6 equals something and I want to solve for x, I just multiply by 6, right? So the biggest number here is 6, right? 6 is the biggest number. So if we multiply by 6, it'll get that 2 away also. And it'll take care of everything. We'll be good. So we're going to multiply everything in this problem by 6. Okay? So what's that going to turn this into? This was 1/2 of t, right? 1 over 2. But we multiplied it by 6. So now what is it? 1/2 times 6 is what? 3. So it's 3t. Be careful with your t's that they don't look like you're adding. Plus, if you multiply t over 6 by 6, you just get what? T equals, you still got to multiply this side. Don't forget. Some people forget. You got to multiply. If you're going to multiply by 6, you got to multiply everything by 6, right? So equals 6. 3t plus t is 4t is equal to 6. And then we divide by 4. So t is equal to 6 over 4, which is 3 over 2, which is what as a decimal? Yeah, 1.5. And how long are we talking about here? We're talking about hours. It doesn't matter because we're just writing numbers. Only numbers are allowed in your answer. So 1.5. Now, it says answers that are mixed numbers must be entered as an improper fraction or a decimal. So that means the two things you could put in are 3 over 2 or 1.5. I would put in the decimal just because there's always that possibility if somebody puts in 6 over 4, they're going to count it wrong because it's not simplified. Right? 6 over 4 is not simplified. A decimal is always simplified. Right? So you either, the two answers that they accept here are 3/2 or 3 over 2 or 1.5. Everybody see how I got that answer? That's going to be a super easy, like if you can go find the work problem at the beginning of the exam, or is one of your first ones to do, it's a super easy one to remember. It's time over how long it takes one person plus time over how long it takes the other person. Obviously, we're adding because we got 2 people working, equals 1, the whole. And then you just solve it for time. So I think that's actually one that, again, can be easy to do. That's number 9. All right, let's move to question number 10. The 2 functions are shown below. What is the y value when they equal each other? So I want you to graph them, either on your on Desmos, on your phone, on your calculator, whatever. Graph those 2 functions. And then we want to find the y value when they equal each other, when f of x equals g of x. When the 2 equations are equal, what's the y value? That's 9. That's the that's the data. And then can't teach somebody if I don't know. Oh. Okay, so everybody see, now they're asking for the y value, okay? So the most commonly missed answer here is the x value. So let's go through how you would do it first. So we're going to say y equals 2x to the third plus 2x minus 3. And then y equals negative 0.5. Absolute value sign. If you can look for it, it's on Desmos, but if you type ABS, I think it will give it to you. I thought it would. Yeah, it still did it, even though it doesn't have the bars, but whatever. Absolute value of x minus 4. You can find it also here. The absolute value bars are, y'all know it better than I do, don't you? Where is it?
It's right above the ABC.
Right above ABC.
It's the A and the
Right here, the A with the lines. Yeah, I couldn't see. I'm sorry. There it is. So there's the absolute value bars. If you want to do it that way, let's do it that way just so. And x minus 4. Either way is fine. If you forget, you type in ABS. That's like sometimes I don't feel like going and doing the square root. I just type SQRT is square root, and it does that for me too. Okay? All right, so we're looking for when they're equal each other. They equal each other when they what? When they intersect, yes. So right here is where they equal each other, right? So the answer would be what? You could say negative 1.75, or if you want to, you could say negative 7/4, but there's no reason to, right? But they will take the fraction as well, but there's no point in changing it to a fraction. But some people do just because they like to, whatever. But it's negative 1.75. So make sure you read the problem. A lot of people don't read the problem sometimes. They love to ask, sometimes they'll ask, what are the x and y, what is the sum of the x and y values? And you have to add together where they intersect. Or just something weird, So you have to be careful with what they're asking. If you notice, a lot of these early problems are not multiple choice. So you've really got to know. But so far, that's our 5th out of 10. There were 10 right here that weren't multiple choice. 5 of them we used Desmos, just graphing them, and we were able to get 5 of those correct just by using Desmos. Okay, I'm going to give you, let's take a 5-minute stretch break. If you need to go to the bathroom real quick, that's fine too. Let's take 5 minutes just to relax for a second. Relax your brain, relax your mind. Yeah, go to the bathroom. So in this question number 11, I've got 48x to the third minus 243xy squared. The first thing you should notice is look at all A, B, C, and D. They all have a GCF. So the first question that I'm asking myself is the GCF of this problem, the greatest common factor, is it 3 or is it 3x? 3x, right? They both have an x, so it's 3x. So A and B are gone, so I'm 50% now, just by knowing that. So it's 3x. So let's divide this by 3x. 48 divided by 3 is 16. X squared, and take away an x is, or x to the third, take away an x is x squared. Minus 243 divided by 3 is 81. And x, take away an x, that means there's not one, and you have y squared. Okay? So now you have 16x squared minus 81y squared. And this is one of the things that I had on my list. This is one of the things I had on my list here, is that the difference of squares is a formula that you need to use. So, difference of squares happens when? You need to know when it might happen. The difference of squares happens when you have a difference, meaning you're subtracting, two things that you can take the square root of evenly. So 16x squared. If I say, what's the square root of 16x squared? That's what? 4x, right? So you write it in both places. If I say, what's the square root of 81y squared? That is 9y. And you write it in both places. So you put a plus on one and a minus on the other, and you are done. So find where that one is. That is what, D? Yep. And that is the end. Now, you see B looks similar, but they forgot to take out the squared. You see that A, they did two minuses. C is two subtractions. D is the only one where you have the adding and subtracting. So, again, they're making them like as similar as possible, but still, breaking them up a little bit. Okay? So that was number 11. We'll move to 12. Which choice shows P of X? So this is graphing. We've got to graph these. This is a Desmos question again, which is good. Okay? Now, on a Desmos question, notice this says multiplicity of 2. A multiplicity of 2 means when you've got a graph coming down and it hits a point and then it goes back up. That's what they call a multiplicity of 2. So this is 2. Multiplicity of 1, that means this is 1. Multiplicity of 1, this is 1. So how many zeros there are? There are actually 4. Okay? Which means there's a I don't know if you call it a formula. There's a theorem or a rule that says you have as many zeros as your highest degree, right? So that takes A and B out of the equation because you have negative 1, 2, and 4, but negative 1 has a multiplicity of 2, meaning it happens twice. It hits negative 1 and then it hits negative 1 again. So you really have 4 zeros there, okay? So that means we're either going to see the answer as C or D. So we only have 2 to plug in. So we plug in C. If C's not right, notice we don't have to change much. Just this from add to subtract and just this from subtract to add. So there's not a whole lot to change. So we go to Desmos. This is the 6th time that we're going to Desmos out of 12 problems. So just trying to give you an idea of how important it could be. We're going to go y equals x to the 4th minus 4x to the 3rd minus 3x squared plus 10x plus 8. Y, and that's the first one. I'm going to go ahead and type in the second one just for fun, because I don't know if the first one's right or not. And do you know, if you type them all in, you can just turn them off if you want to, and then you can turn them back on. So let's look at, we're looking for, it has negative 1 with the multiplicity of 2. That means it hits negative 1 and goes back up. And then it also crosses at 2 and 4. So notice, there's your multiplicity of 2. Because it hits negative 1 from this way, and it also hits negative 1 from this way. So if you ever see it say a multiplicity of 2, that's what that means. A multiplicity of 1 just means it goes straight through the point. It doesn't stop at the point. And then it's also at 4. So it's that first one. Now look at the second graph. Notice the second graph has a multiplicity at 1, negative 2, and 4. So notice not a big difference there, right? Instead of negative 1, 2, and 4, it was 1, negative 2, and negative 4. So they were hoping you would just do it backwards possible. You might got a question on 12. I actually think these are very, very, very possible. I know it's been like a weird semester, but you've gotten the material, and this exam, while still difficult, I feel like actually does cover what it should cover. It doesn't throw in things that are, crazy. All right, let's go to 13. 13. If the graph f of x equals k x minus 2 to the fourth, k is positive, what is the effect of the graph as k increases? So I like to pick a number for k. So let's pick a one-digit number. It's positive. Let's pick a one-digit number for k. Give me a number.
5.
Huh?
5.
Sure. 5x minus 2 to the fourth. And now I want to know what happens as k increases. So how about a bigger number?
10.
10. X minus 2 to the fourth. Okay? Now I may have to zoom in to see this, but that's fine. So as k increased, so the blue is when k increased. As k increased, what happened to the graph? What's happened to the graph? Huh? Got skinnier or more narrow, right? Does it got more narrow as k increased? Now, so that would mean it's not shifted up or down. It's either stretched vertically or horizontally. Now let me explain. Here's the red, right? The 5. As k gets bigger, it's going to go this way. This way is what? Vertical or horizontal? It's vertical. It's going towards the y-axis. It's getting closer to the y-axis. If you stretch something horizontally, you're pushing it down to the horizon, right? So if you stretch something vertically, you're pushing it closer to the y-axis. So that blue is getting closer. That second one is getting closer and closer to the y-axis. Notice if I put in, let's say I put in 100. See how close it's getting now to the y-axis. It's stretching closer vertically. Remember, vertical, so what you need to know on this one, if you need to write it down, it's fine. Vertical is the y-axis. It's getting closer to the y-axis. So if it's stretching vertically, you need to know what that means. That means it's getting closer to the y-axis. If it's stretching horizontally, it's getting pushed down. It's getting closer to the x-axis. Okay? Anybody with a question on that? Good. Number 14. Number 14, we get piecewise functions. Those are fun. So we have a piecewise function. It's been a little while since we've seen one of these. And it says, what is the value of 3h of 2 plus 4g of 1? This actually, again, I've said it a lot, but this is actually kind of an easy problem. So we go to h because that's the first letter we see, h. Okay? So here's h. We want to plug it in when h is 2. So when h is 2, which one should we use? The bottom one, because that's when it's greater than or equal to 2. The top, it's only when it's less than 2. So we're going to use this one because it's 2, right? So let's plug in 2 for h. So 4 times 2 plus 1. What is that? 9. Then what do we need to do to that? So h of 2 is 9. We need to multiply that by 3. So that's 3h of 2. So h of 2 is 9. 3h of 2 is 27. Okay, so that's all we had to do there, is multiply it by 3. So we did that. Now, so we got the first one. We got 3h of 2. All right, let's look at the second one. 4g of 1. So which equation do we use, top or bottom? The top, because we're talking about 1. We're going to plug in 1. 1 squared plus 2 is equal to what? 3. And it says 4g of 1. So we're going to multiply that by 4. So 4 times 3 is 12. And those were our two answers, 27 and 12. Now, it's wanting us to add, right? It says add those two. So we're going to say 27 plus 12 equals 39. And that's our final answer. And that's definitely on the exam, piecewise functions, but definitely possible.
How many questions are on this? 60.
That's 60. $50 are scored. 10 are field tests. You don't know which ones they are. As always, they get them ready for the next year. So if there's 60, 50, your grade will be out of 50. I mean, you're right out of 50. And because they're like all computer based, typically, not always, but typically you guys would take it and be done at 12, and a lot of times by 2:30 I have the results. Sometimes it'll be the next day, but at the latest it would be on Friday. I would already have it. 15. Okay, question number 15 says, what is the value of h of -4 plus 3h of -2? Guess what? We're looking at a piecewise function yet again. Okay? In this one, you only have one function, so it's really not that bad. So h of -4, which one are we going to use, top or bottom? Top. So -1/2 times -4 minus 15. You can put that in your calculator. You can try to work it out in your head, however you want to do it. Somebody, if you get it, tell me.
-13.
-13, yep. This is -13. That's that first one. That's h of -4. Let's do h of -2, and then remember that we got to multiply it by 3. So h of -2, it's going to be when it's greater than -4, so we're going to use this one. So 20 minus 3 -2 squared. Yeah, 8. And we want to add them. Well, I almost got caught there. We don't want to add them yet. We want, that was h of -2. We want 3 times h of -2. So we're going to multiply by 3. So 3 times 8 is equal to 24. Then we want to add -13 plus 24 equals 11. And notice this is a piecewise without multiple choice. So we get one with multiple choice, we get one without multiple choice. So again, they will kind of give you a little bit of both as you go through the process. So -13 plus 24 gives us 11, and we enter our response. So a lot of these, not a lot, but I think they said 15 of the 60 are not multiple choice, and another 45 were. So like a quarter of them are where you have to do that. Okay, so question number 16 on the released questions. I actually think this part's easy. Some people get a little confused on it. You're just looking at the graph, and they've already given you the graph, which is awesome. So here's the graph of a function. Click and drag each interval into the column that describes the function on that interval. So basically, you got 4 answers to go in 4 places. So positive means it's above the x-axis. Negative means it's below the x-axis. Increasing means it's going up. Decreasing means it's going down. Could be as we're reading from left to right. So we're going up, down, up. Okay? So decreasing, let's look at a couple things. First of all, let's look at what's happening from -4 to -1. So we're looking at our x's. So from here, from -4 to -1, it increased and decreased. So it definitely ain't that. So from -4 to -1, what do you realize about the graph? Yeah, it's always positive, right? From -4 to -1. So that means it's always positive. Okay, good. From -2 to 0, let's look. From -2, we're talking about our x's. So our x is at -2. Until our x gets to 0, it is what? It's decreasing. Now we're down to only two things left. From 0 to 2, you have to be careful. So from 0 to 2, you see it's down here. That could be negative and it could be increasing. So we want to go to the next one. From 0 to 4. So from 0 all the way until you get to 4, that one is doing what? Increasing, because it's negative and positive. So it couldn't be negative. 0 to 4 has to be increasing. And 0 to 2 will be that it is negative. Okay. So all you're doing is just looking through and saying, where's the graph? Is it above the x-axis, below the x-axis? Is it increasing or decreasing? Most common mistake was between that 0,2 and 0,4. That 0,4 is increasing. 0,2 is also increasing, but it's the one that's fully negative. So that's how you have to get that. Okay? So the issue here is, like, you could get 2 of the 4 right and just mix up the other 2, and there's no like half credit, partial credit, none of that. You miss the whole problem. On the other one, it's like a quadratic. There's like an A, B, C. You miss the whole problem. If you could get the A, the B right and miss the C, and you miss the whole problem. So the ones where they're gridded responses is like there's four choices. You got to get all 4 right to get it. There's no partial on there, which would be nice if there was, but you got to get all 4. All right, let's go to 17. Here's the function. It says, what is the distance? So we're getting to another Desmos problem. What is the distance to the nearest hundredth of a unit? Hundredth means how far? How many decimals? 2. So 2 decimal places. Between the 2 zeros, that's the x-intercepts, right, that are closest to each other. So a lot to look at here. What is the distance to the nearest hundredth, so within 2 decimal places, between the 2 zeros, the 2 x-intercepts that are the closest to each other? So you look at this, it goes to the third power. There's going to be 3 x-intercepts. But we want to look at the 2 that are closest to each other and figure out how far away they are. Okay? So y equals 4x to the third minus 5x squared minus 23x plus 6. There are 3 of them. Which 2 are the closest together?
-2 is 0.25.
Yeah, -2 and 0.25. So from 3 to 0.25 is 2.75. Okay? From 0.25 to -2 is how far? I mean, you should know.
1.75.
No. It goes from -2 to 0, right? And then it goes to 0.25.
It's 2.25.
2.25, right? Subtract them. -2 minus 0.25, right? Or say 0.25 minus -2. Don't say 0.25 minus 2. It's a -2, right? So either way you subtract them, you should get the distance is 2.25 between those 2. 1.75 is probably the most missed, I guess, answer, followed by 2.75.
Wait, so if we put a negative, it would be 1.
Yes, because it says, what is the distance? Distance is always positive. So it wants to know how far away are they from each other. They're 2.25 away from each other. You can't be a negative distance from somebody. You could be behind them, but you're still 5 feet behind them. So when we talk about distance, it always has to be positive. So that's another good answer. Because some people probably did put negative 2.25 on this, even though it's a positive. All right, 18. Which function does not have the set of all real numbers as its domain? So let's think about this. Okay, I think we can do this without graphing or anything. So domain is your what? X. So your domain is your x's. So that's the first thing you need to know. Domain is your x's. Now, all real numbers means that it could be any number. There's one of these where it can't be any number. Okay? Because it has what we call a restriction. All right? So, for instance, in a fraction, kind of giving away the answer here. In a fraction, what can you not divide by? You can divide by a negative. You can't divide by 0. Yeah, you can't have a negative square root. You can divide by a negative, and you just get a negative, right? But you can't divide by 0. So what number would make this 0 on the bottom? What number would make the bottom 0? Negative 3. If you did negative 3 plus 3, it would be 0. So let's just think, for instance, if the number was negative 3, so in this problem, x cannot equal negative 3, because if it did, negative 3 plus 1 equals negative 2, and negative 3 plus 3 equals 0, right? And negative 2 divided by 0 would be no solution. So, all real numbers is not its domain because it can't be negative 3. So what they're testing you on there is, do you know that you can't divide by 0? If you do know that, then do you know that there's what number it can't be? You didn't have to know that negative 3 was the number, but you did have to know that it would make the bottom 0 and you can't divide by 0. Okay. You could put any number in for absolute value and it'll give you a number. Doesn't matter what number you put in. You could put any number in for an exponent and it'll give you an answer. It doesn't matter what you put in. You could put any number in for cosine and it'll give you a number. It doesn't matter which one you put in. But you cannot put a negative 3 in for b because it will give you 0 on the bottom of the fraction. And that will not work. That'll give you no solution. Okay, 19. 19, we have an equation. It says, what is the value of x to the nearest 10,000? There's two ways of doing this. You could use the calculator, and I'll show you that in a minute. You could also know the rule from exponents and logarithms. And I really like to know the rule from exponents and logarithms because it makes this one easy. Okay? So notice it's called the, anybody remember? Swoosh method. Okay? Take this number and you swoosh it all the way around. So log base 9 of 48 is equal to negative 3x plus 2. Okay? It's the swoosh method. You write log because you're changing it from exponent to log, and you go all the way around the formula. Now, log base 9 of 48. Some people say, well, how do I type that in? So we look on Desmos for that. And if we're trying to type that in, let's just go on here. If we're trying to type that in, we're going to say go here to your calculator. You're going to go to functions, miscellaneous, and you're going to see log. What is that?
That's for the little x.
That's the base, right? Yeah, log base. So 9 and then 48. Thought I might have messed up. Yeah, there it is. Log base 9 of 48. I got one. Now, this one says to the nearest 10,000. Does everybody see how many decimal places that is? If you didn't know, you could look at your answers. It's 4, right? So 1.76, whatever. 1859555. So that is log base 9 of 48. Let's say 19. Okay, to solve this, what should I do next? It's just a math problem now, right? Algebra. Subtract 2. So when I subtract, I get negative point. I'm trying to do this in my head here. Negative point, you can tell me if I'm wrong, 2381. Then I'm going to divide by negative 3. So I got negative 0.2381 divided by negative 3. And remember, Desmos will do that for you too. I get 0.0794. I hope that's an answer choice.
It is.
Good. I got 0.0794 as my answer. Now, let's do it on the calculator for those of you that might be a little lazier. That's okay, I'm not saying lazy. For those of you wanting a different option, let's take the calculator, let's say 9, let's say y equals 9 to the, oops,
That's 0.
thank you. Negative 3x plus 2. Notice I kept it in parentheses so it would all stay up in the exponent. And then let's say y equals what? 48. Okay? Where do those two cross is my question. Right here. Everybody see where they cross? 0.079. How nice is that? Anybody need to see how I got that again?
Yes.
Okay, I typed y equals 9 to the negative 3x plus 2. And I typed y equals 48. So I typed the left side of my equation in the first one and the right side of my equation in the second one. It looks like this, but you know y equals 48, that's going to be way up there at 48. So you've got to zoom out. So you've got to zoom out to get to 48. There it is. Then you just click on it, and it'll tell you where they intersect, and you get 0.079, which is going to give you that answer choice. I like that. I like what I did too, but I mean it's unnecessary if you're going to use Desmos. I mean, what's the point? So gives you two options again. You could do the work on there to make sure. You could check it with your graph. You could use your graph if you forgot how to do the swoosh method. You got multiple options, which is nice to have. Okay. I always like to have more than one option when I'm taking a test, when you're doing something. All right, let's look at 20. It says in number 20 that the diagram below shows an angle, the angle they call theta, that little angle mark. All that angle mark is saying is that it is graphed on the XY coordinate plane, so that just means on a regular graph. There it is. It says segment RT, so that's straight across, is the initial side of the angle. And segment RM is the terminal side, that's where it ends. Segments RT and RM are both radius. They're both a radius. They're called radii when you have more than one radius of the circle at 0, 0. So the x-coordinate of point M is -1/2. What is the measure of theta to the nearest thousandth of a radian? So this is -1/2. Is what they're saying the x is on this one. Oh, how nice it would be to know. How nice it would be to know the angle when x is -1/2. So if you remember these angles, 0 to 90, right? 90 to 180, 180 to 270. Okay? Right here, x is at 0. Then it would go to -1/2, negative square root of 2 over 2, negative square root of 3 over 2, and -1. If you're right here, what would your angle be at? If your angle went all the way to right here?
270.
270, right? Does anybody remember on the unit circle, what's the one beside 270?
240.
240. It's 240. So the angle is actually 240 degrees. Now, that's the angle. But this says, what is the measure to the nearest thousandth of a radian? Okay, and I got to go through, that's question number 20. A radian on here, let me give you the formula. So the angle is 240 degrees right there. A radian is, how can I change 240 from degrees to radians? So how do I change something from degrees to radians? Take 240 and do what? Anybody remember? You need to. It's really not hard. It was like we had a worksheet on how do you change something from radians to degrees and from degrees. Yeah, something 180. It's divide by 180. So you divide by 180. 240 divided by 180, and I want to reduce that fraction. So what is 240 over 180, and I reduce that fraction?
4/3.
4/3. And then when you changed it from degrees to radians, anybody else remember what you had to do? You put pi on top. Absolutely. So 4 pi over 3. So my angle is actually 4 pi over 3. Type that in your calculator. 4 pi divided by 3. And you should get your answer.
It's the
Yes, it is. 4.189. The end. Now, what you need to know is, you need to know these go 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270. So knowing that that was -1/2 meant it was the next closest one to 270.
It goes by what?
It goes 30, 15, 15, 30 as you go around. And so knowing that that was -1/2 actually told us that that angle was 240 degrees. So 4.189 was our answer in radians. So we changed it from degrees to radians, and then we actually plugged that in the calculator. Typically, in our class, we left it at 4 pi over 3. We never typed that in the calculator because there's no reason to. They just wanted you to, just to give you an extra step. But, oh well, it's just typed it in the calculator. All right, so that's 20. So that's our next break, 5-minute break. For our online countdown here. And we will return in 5 minutes. Everybody feeling good? You should feel okay about it. I mean, I know it can be hard, but and there's more than just this on it. That's why that is in Math 4. So that unit circle is in Math 4. It's in Trig. It's in Pre-Calc. It's in any of those. So, I mean, you'll see it again, I would assume. The only time you won't see it is in AP Statistics. which you should take next, just let you know. But that's the only class you would not see the unit circle that would be coming up in your future classes. The others, you will. Most people, if you take, honestly, I say that laughing, but typically the best way to do, if you're wanting to do an AP math class, statistics is really good as far as like real world. I say it because I teach it, but you get real world problems, and it goes with Math 3. So like there's a whole unit that we've already done in statistics in Math 3 that we've already covered at least somewhat. So it does match up pretty well with it. All right. Here it says, number 21 says a function f of x equals a sine bx plus h, and it has the following properties. It has a period of 6, a minimum value of 2, and at 2.5, so where it says f of 2.5, what this means is, you need to know what this means. This means when x is 2.5, y is 5. Okay? So if x is 2.5, y is 5, meaning that y is twice as much as x. It's like double, right? Okay? So what you want to look at here is the lowest it can go to is 2. The period is 6. So period, a lot of people probably forgot how to get the period. The period is 2 pi over b. And we know that the period is 6. So what we're trying to find is b, right? So let's solve for b. So to solve for b, let's get it off of the bottom. So we multiply by b, so we would get 2 pi equals 6b. And then if we solve for b, we would just divide by 6. So b equals 2 pi over 6. 2 over 6 is just 1/3. So how about just pi over 3? So we got b. So that's awesome. We got b. Now, we need to get the other two. Now, the thing with the other two is it's really easy to just plug them in and see if this point is in that graph. Is this point in the graph? 2.55. So let's go to Desmos and let's say y equals, and there's our formula up here. Let's say y equals, let's try the first one. 2 sine of pi over 3 x plus 2. Let's just say plus 2, okay? And so in this one, I'm on 21.
We're done.
So in this one, I can look at it. I have to change my graph to radians to look at it because I'm in pi. I'm doing pi, okay? So I got to change it to radians because I'm doing pi. Anytime you're using pi, you want to be in radians if you're graphing. Anytime you're doing degree, the other one you want to be in degrees. Most of the time you're in degrees, but because we're using pi in this, I'm in radians, okay? So here's what it looks like. Now, does this one go through the point 2.55? Well, you can figure that out. I can type that point in, 2.5, 5. There's that point. So does that one go through the point? No, it doesn't work, right? So let's try, what other numbers could work? 4, 6, or 8, right? Let's try it. 4, does that work? Oh my goodness. There it went. The end. That's all you gotta do, right? You try 6, oh, didn't work. Try 8, oh, didn't work. So we got lucky. It was 4. The end. So we're trying to get it to cross through that point. All I did, I was just choosing numbers. I could have tried 4 and said 2. Nope, doesn't work. 4. Nope, doesn't work. 6. Nope, doesn't work. 8. Nope, doesn't work. But I started with 2 because that was my first number there. That was my first entry in line 1. I started with 2. And in line 3, I had 2, 4, 6, and 8, right? So I started trying 2. It didn't go through that point. So I started trying 4, and then it did go through that point. And I said, oh, I've got it right. Now look at my graph. The period of this graph is 6. The minimum value, the bottom, the lowest it goes to, is 2. So that works. When x is 2.5, y is 5. That works. And the only other thing it said was A, B, and H are all positives. 2, pi over 3, and 4. They are all positives. So we are good to go. 2, pi over 3, and 4. The end. So we got number 22. It says, what is the volume of the figure created by rotating the triangle around y equals x? I'm going to show you this. This one's a little bit trickier on 22. Not my favorite one in the world. But you have to, the goal in 22 was to draw a triangle using your graph paper with those 3 points, and then to find the radius and the height. And they actually give you the formula for a cone, and this turns into a cone. So let me see if I can find the work for you here. But this is I had it for you right here, I believe. No. Yes, right here. So in number 22, it's a lot, and I understand, like, when I was going over it last time, I said this may be one that they just not going to get. But I am going to at least show it to you. So it's what it looks like on 22, okay? And it is a lot, so don't freak out. Do you have graph paper on the exam? So they do give you graph paper. So you have graph paper. That's one good thing. Notice what you would do first. I'm just going to kind of try to break it down slowly. The first thing you would do is draw points. At 0, 0, you would make a point. You see a point there? At 6, 6, you would make a point. That's right here. And at 9, 3, you would make a point. You would make those into a triangle. So that's the red part with the orange points. That's what you would do first. Next, it says, what is the volume of the figure created by rotating it by y equals x? Y equals x, if you type that in your calculator, is just a line, a diagonal line. Okay, it's a line with a slope of 1. That's what y equals x is. So if you take this triangle and you rotate it across that line, you actually get the same triangle on the other side, right? So now you've got a triangle here and a triangle here, which now looks like a cone, is what it looks like. That's what they were saying. It looks like a cone. And so what the formula for the volume of a cone is it's actually in the formula sheet for Math 3. And I know that's hard, but for the volume of a cone, it's pi r squared times the height divided by 3. Well, the key in this problem is you don't know the radius and you don't know the height. So to get the radius, you got to find the distance formula from A to B. That's your radius of the cone because it's only half of the cone. So the distance formula is subtract your x's squared plus subtract your y's squared and take the square root of that. So you get the square root of 18, which is 3 square root of 2. The height of the cone is actually called, they call that h. The height of the cone is these 2 points, 6, 6 to 0, 0. That's how tall the cone is, right? It's that high. So 6 minus 0 squared plus 6 minus 0 squared is 36 plus 36, which is the square root of 72, and that's 6 square root of 2. So that's your radius and your height. So you plug in your radius, you plug in your height, and you try to get your answer there for the cone. A very, very, very difficult problem. It is possible, so I'm not telling you it's impossible to do, but this would be one that would be at the highest level of those. And it's not going to kill you if there's something you miss on that. But use your graph paper, draw it out, use the formula that they give you on the formula sheet. Understand you have plenty of time, right, to work with it. And do the best you can on a problem like that. That's all you can do. Don't just guess. Go through, and that's why we're giving you one now to see on those released questions. Okay? All right, so let's go to number 23. Number 23. It says in a parallelogram MNPT, the measure of angle M is 6x plus 10. N is 5x plus 10.5. Okay, MNPT, parallelogram. So let's draw it. Here's what a parallelogram would kind of look like. That's not the best one in the world, but it's good enough. MNPT. They got to go in order. So if it says MNPT, you've got to make sure they go in order. MNPT. Like, it doesn't matter what order, but you got to be able to go to each point and say MNPT as you go through. All right. So, a couple things we know. Angle M is 6x plus 10. Angle N is 5x plus 10.5. Okay? What do you know about M and N in a parallelogram?
Oh, their opposites are equal to each other?
The opposites are equal. M and P will be equal. N and T will be equal. But there's something about M and N that you should know too. Yes, they add up to 180. So corresponding angles or consecutive angles would be what we call it. Consecutive. Consecutive angles add up to 180. So 6x plus 10 plus 5x plus 10.5 equals 180 degrees. They add up to 180. Okay? So when you add these together, you're going to get 6x and 5x. That's going to be 11x plus 20.5 equals 180. I'm now going to subtract 20.5. So I get 11x equals 159.5. And I'm going to divide by 11. If somebody could give me that answer.
14.5.
Exactly. Good. 14.5 is x. Now, 6 times 14.5 plus 10 is going to be angle M. So plug that in. Okay. So if this one's 97 degrees, I guess this one's also 97 degrees, right? Okay. 5 times 14.5 plus 10.5. 83. And if that one's 83 degrees, that means this one's 83 degrees. See what the question asks. How many degrees is angle T? Answer 83. Done. Okay, not as hard as it looks. Not as hard as it looks. What you need to know, you need to draw a parallelogram to make it make sense to you. Then you need to know that consecutive angles are supplementary, meaning that they add up to 180. That comes from one of our early units also. Okay, another early unit thing that we have done that can be easy for us here is question 24. Question 24. You see a rectangle. You've got two diagonals in the rectangle. They intersect at point E. Okay? Right here. So we know I to E is 3x plus 4. I like to write on mine when you're doing that, right? And E to G is 5x minus 6. What do we know about those two together?
8x minus 2.
No, what do you know about those two things? If you added them, yes, it would be 8x minus 2.
They're equal.
They're equal to each other. They're equal to each other. So I want to find what the distance is, so I want to set them equal to each other to figure that out. So 3x plus 4 is equal to 5x minus 6. I'm going to subtract my 3x, so I'm going to get 2x, and I'm going to add my 6 to get 10. And then I will divide by 2. So x is going to equal 5 when I solve that out. Now, if x equals 5, let's plug it in and get what each of those are. So x is 5, so what is I to E? 3 times 5 plus 4. 19. And 5 times 5 minus 6 is what? 19. So they're equal. They got to be 19, right? Now, you see 19 as an answer? Yeah. What is the length of F to H?
38.
Exactly. Because it's 19 and 19, so it's 38D. They would love for you to pick 19. All right. You got to be careful. Draw on it. Write on it. All those good things, okay? Let's move to 25. 25. Very important topic that we didn't get to cover. So, nice time to cover is right now. This is called, there was a unit called Random Geometry Topics. We didn't get to Random Geometry Topics. I had to take that one off the list. This is a triangle, obviously, but it's got all kinds of stuff on it, okay? So, but it gives us enough information to solve it. So, GH is x plus 3. And PG, this down here, is 4x plus 1. And GJ is 2x minus 1. Okay, does anybody know which of those two are equal to each other?
2x and minus 1 and x plus 3.
Yes. 2x minus 1 and x plus 3 are equal. Okay? I'm going to give you an idea. Those three are actually called the end center. This line, and this line all meet those three. Notice this is the hypotenuse of the triangle, so it's not equal. This is the leg of the triangle, and this is the leg of the triangle, and this is the leg of the triangle. Those three actually are all equal to each other. Okay? So, 2x minus 1 equals x plus 3. A lot of times you can see this just by kind of using your, like just looking at it. Subtract x, so you get x, add 1, so you get 4. So x equals 4. So if x equals 4, let's fill in some of this stuff. This would be what? 2 times 4 minus 1? 7. That means this one's also 7 because 4 plus 3. What would this one be? 4 times 4 plus 1. 17. All right, good. Now, what is the measure of segment PG? Well, there it is, 17, the end. All right, but it's all about knowing. But if you didn't know that GJ and GH were congruent, you're not going to get that, right? So you got to know, that's where we just got to remember just a couple little things, and we'll get it. All right, moving on. 26. 26 says, what is the length of a radius of the circle represented by this equation? This is my favorite one because what you should have to do is completing the square on this one. And I can do completing the square to solve this one. And it's really not that hard. We did completing the square with circles, but it's just another formula to learn. So this is where Desmos.
I'm confused on the
This is where Desmos. We'll go back. This is where Desmos helps us out a lot. So on this one, it says what's the length of the radius. The nice thing about this is I can go here and I can say x squared plus y squared minus 4x minus 4y plus 4 equals 0. And it draws the circle. How cool is that? All right. So it actually draws the circle for me without doing anything. Okay, if you get 60 wrong or 59 wrong, you should get this one right. Okay, it draws a circle for you. Now, make sure it's going up by 1, because sometimes depending on how you have your Desmos set up, it might be going up by 2 or 3 or whatever. Here's the center. Remember, the radius is the length from the center to a point on the circle. So what's the radius of this? 2. The end. Okay. Yeah. So 2 is the radius. Okay? So we get 2 as our radius of the equation. Very simple. And there it is. The answer.
It's 2? Oh, okay.
27. All right. David plans to cover the floor of his room with new material. The floor is an isosceles trapezoid. So we got to go back and remember that's unit 1. An isosceles trapezoid. So I'm going to draw it first of all. Let me draw this isosceles trapezoid. There it is. And it says the floor is an isosceles trapezoid whose bases are 16 feet and 26 feet. Now, let's think about it. There's a couple things you do in isosceles trapezoid. You can make it into like a triangle, right? So which base would be 16 feet? These are your bases. This is a base and this is a base. Which one's 16? The top, right? So if this is 16, this is 16. This one's 26. So how much is over here? 5 and 5, right? So there's your 26 feet on the bottom. Very nice. Now, the sides are 13 feet in length. Okay? Each piece of new material has an area of 2.5 square feet. Assuming the pieces of new material can be cut as needed, how many pieces does David need? First of all, he needs the area of the floor. So he needs the area of a trapezoid. And the area of a trapezoid is, I'm going to give you the formula, and I believe it's on the exam. I'm very confident. It was base 1 plus base 2 times the height divided by 2. That's your area. Okay? So, base 1 is what? 16 plus 26. We don't know the height yet, divided by 2. Now, the height is this. How can we get the height? Yeah, Pythagorean theorem. Good. A squared plus b squared equals c squared. 5 squared plus b squared equals 13 squared. 13 squared minus 5 squared equals 144. The square root of 144 equals 12. So 12 is our height using the Pythagorean theorem. Hello? Okay. No, she can come on. All right, bye. So 12 is the height. 12 is the height. So the area is going to be 16 plus 26 times 12 divided by 2. Anybody want to go for that? $252. Now, do you see that as an answer choice? Yeah, it's wrong. Because it says, how many pieces does he need? Well, the area of the whole trapezoid is 252, right? How much does each piece take up? 2.5. So 252 divided by 2.5 is how many pieces he will need. Yeah, it's 100.8, which rounds to 101. So we get 101 pieces is how much he's going to need in question 27. Okay? A little bit there, a little bit. Not too bad. A little bit of work. All right. Now, let's move to 28. Number 28. This is a statistics one from this unit. Which method is most likely to produce a random sample of 5 students from a school club? So, a random sample is something that is representative of the entire population. So, if I want to get a random sample from my school club, which one is the best way for me to take a sample from my school club? C. And that's super easy, right? Selecting 5 club members from a hat containing the names of all the members. So you select 5 club members from a hat that has all the members there. So you're randomly selecting those 5. In A, you're only picking brown hair, so that's biased. In B, you're only picking people who raise money, that's biased. And in D, you're only picking people who arrive last, so that's biased. So C is the only one that is not biased. All right, 29. A high school randomly selected 75 of the 200 seniors at the school to take a sample college entrance exam. The mean grade point average GPA of the seniors selected was 2.85. The standard deviation was 0.4. Select all of the statements that are true. Note, the margin of error is 2 times S over the square root of N. So they give you the formula, which is nice. Where S is the standard deviation and N is the sample size. All right, so X bar is the mean. We're going to call it X with the bar. That's what the mean is in your calculator. The mean, it tells us the mean GPA was 2.85. Okay? S is your standard deviation. That was 0.4. The margin of error is 2 times S over the square root of N. That would be 2 times 0.4 over the square root of, what is N? That's the key in this one. Big key. N is your sample size. How big is your sample? Be careful before you say it. How big is your sample in this problem? How big is your sample? What did you say? How big is your sample? Is it 75 or is it 200? That's the problem, right? It's 75. Your sample is the people you actually get information from. Your population is all the people you're interested in. So we're interested in all 200 seniors at the school, but we actually randomly select 75 of them. So our N is 75. So 2 times 0.4 over the square root of 75. That should give you, if you put it, you need to put it in parentheses like this. You should get 0.092. That's your margin of error. Okay? So notice click all the statements that are true. If you don't read that last thing, like some of you don't read a lot, if you don't read that last sentence and you just click margin of error is 0.092, it's going to be wrong. Okay? So the margin of error is about 0.092. So the first thing is not right. So we click 0.092. Then look down there. Okay? You need to know this. When you increase sample size, decreases margin of error. Now, your margin of error is how far you're off. Like, error is bad, right? You don't want a lot of error. So think about it like common sense wise. If you get a bigger sample, more people, more and more and more and more and more people, then your error should go down, right? Your margin of error. If you sample less people, you're going to have more error. Your margin of error is going to go up. So if you change your sample size to 125 seniors, now you went from 75 to 125. So you sampled more people. So your margin of error should go down. Now, if you don't know that, all you got to do is plug 125 in here, and you'll get a lower number, and you'll hopefully get it right. But the bigger your sample, the lower your margin of error. That's what all that means is you're less likely to make an error when you have a larger sample. Okay? So that is number 29, and I know we're all excited now. So number 30, we hit the finish line here. Number 30 says the police chief of a town is trying to determine the average speed of drivers on a specific road. The police chief took a random sample of the speeds of 100 drivers on the road. The mean was 48.5 miles per hour. That's your X bar, right? The standard deviation was 2.5 miles per hour. The police chief wanted to decrease the margin of error in his next sample. What choice would decrease the margin of error? Increasing the sample size, right? So if you increase your sample size, that's a huge, obviously you see that's two questions. Now, do they think that's important? I would say yes, because that's 2 out of the 30 released items is on that one little topic on the margin of error. Now, notice in both problems, they gave you the formula for the margin of error. So they don't expect you to know the formula. They expect you to understand that if you get a bigger sample, your error should decrease because the bigger your sample, the more accurate you should be. So that's what they want you to know, okay? So it is increasing, or to decrease the margin of error, you would need to increase your sample size. And that is the goal for these questions. All right, so I'll post this on there, the questions with the answers. So you have the answers anyway, but I'll post it on Canvas. I will post the video. This video is, we're at 2 hours and 9 minutes, and I even paused it during the breaks. But so at 2 hours and 9 minutes, that's a long one, but it's on there. You can skip through. Like, again, like if there's some that you know, then don't worry about it. But if there's some you were a little confused with, go back and let me explain it again. Like, watch it again. Rewind it a little bit to that question. Go to question 17 and rewind it. But again, make sure you get here on time on Thursday. Make sure you pay attention. Take your time. So if I'm pacing myself, if I have 8 to 12, then, I'm trying to get 15 or 20 questions per hour. That's it. I don't need to get 50 done in the first hour. I don't need to rush. There's no rush needed at all. You really should be sitting there relaxed, but not asleep, but relaxed. I marked off about 25 out of these 50-some things that I think are on there. I'm going to read them real quick to you just so you know in your brain and so it's recorded. And then Wednesday, I said I'll go over like a last-second review with you. But
I'm listening.
thank you. So some of these, the first one, so let me go through all these. You ready? See how many of these you just try to think how many you remember. The unit circle and what is cosine and sine. So cosine is x and sine is y. Inverse of a problem. Making a table into a graph. The difference of squares. When does f of x equal g of x? Two equations equal each other. Piecewise functions. A point of discontinuity. A piecewise, plugging in a number in a piecewise function. Translation, up, down, left, or right. An absolute value equation. Logarithms, the swoosh method. A work problem. That was the one like how much time does it take for them to complete the task. The remainders using synthetic division or the remainder theorem. Equivalent expressions. That's where we could graph them, right? Finding the zeros. What is the sum of the zeros? Sometimes they'll ask. The unit circle angle measure in radians. We did one of those. Synthetic division. We did not do one of those today. Matching exponential equations to a graph. What is the common denominator? What is the area of a shape? What is the amplitude? Amplitude is the number in front. We didn't talk about that specifically. Amplitude. What is the volume of a cylinder? They give you that formula, I believe, on the exam. What is, a common denominator? We saw that again twice. What is the value of x in an absolute value equation? What is the radius of a circle? We did that one, right, by just graphing it on Desmos. The diameter of a circle. Can you find the area of the circle if they give you the diameter? The area is pi r squared, but if they give you the diameter, you know to divide it by 2 to get the radius, and then do pi r squared. Arcs and central angles. Circumference and arc length. So those are things that we may need to look back on. I said Wednesday I would look over some other things. Rational division. That's the one where we flipped it and changed it to multiplication. That's 30 of them. I'm over halfway. The difference between a population and a sample. We just kind of talked about that right there. 75 was the sample. 200 was the population. Horizontal and vertical asymptotes. An experiment. So looking at experiment. Knowing if it's an experiment or an observational study. What has the greatest rate of change? So what is increasing the fastest? Matching equations to graphs. The x minus ideal is less than or equal to the tolerance, so that absolute value problem. Transformations, again, we talked about. What are the zeros of a function? I marked that off because we did that today. Remember, the zeros are the roots, the solutions, the x-intercepts where it crosses the x-axis. The circumcenter of a triangle. That's actually the triangle problem that we did. That's the name of it. That's what it's called. Which equation is the graph? So basically it gives you a graph and it says which of these 4 equations is that graph. That would be Desmos. Piecewise functions. So again, another piecewise functions. The circle, the graph that matches the equation of a circle. Again, you can use Desmos. Where the 2 equations intersect. The length of a line to a circle. Remember when you had to do those circles and you had to find how long the lines were outside of them. A random sample, how to best get a random sample. We just talked about that. That was one like picking one out of a hat or whatever. The number of zeros that there are when you may have how many real zeros, that means how many places does it cross the x-axis. How do you know how many total zeros you have from a graph? So I could have a graph that's x to the 5th power, but it may only cross the x-axis twice. That means it has 2 real zeros and it has 3 imaginary zeros. So you know how many zeros it has in total, what power it goes to. You know how many real zeros it has, but how many times it crosses the x-axis. If it hits the x-axis and goes back up, that counts as 2 because it's a multiplicity of 2. And then the side links that we talked about on there, and really that was it. That was all 50 some that I could talk about that I just said real quick. So we covered about half of those or so from these released questions. Then the others I'll try to touch on Wednesday, and then we'll go from there. Okay, but you can listen to any part of it as you go through. But I think you'll be fine. I know it wasn't the best, like we weren't able to do it in the best method this semester, but I think that we were still pretty successful, and I think you'll be fine on the exam. There's no reason that you shouldn't be able to get through and pass it. Okay, you all are smart and you've done a good job, so make sure you do that. The main thing I want you to do is get your grade as high as possible before the exam too. So use tomorrow and Wednesday to, obviously you want to study a little bit at some point, but use it to look back. I've updated every grade. So in Power School and in Canvas, every single grade up to like an hour before we started this review has been updated and put in. And so every grade's updated. And so if there's something you haven't turned in, if you have a 0 on it in Power School, that means you got a 0. So you need to go back. You have through the end of the week. Friday, it's over. So we have to turn in those. And Canvas is going to shut down on the 18th. It's over. So after Friday, you won't even be able to log into the course. So that's why it's very important to make sure you get it done then and you get your grade done at that point. Does anybody have a question on the exam? When you come in, before you catch that, when you come in on Thursday, they'll let you know. You could just come here, but they'll send you to the appropriate room. There's only going to be 12 in each. And you've got me, and you've got Frontier that has a Math 3 class, and you've got my third period that has a Math 3. So there's about 80 students taking the Math 3 exam. And so that means we'll be spread out around about at least seven rooms. Okay? So I don't know exactly where you'll be, but I know it should be around this hallway. And probably the math department, I think, for the most part, is covering the math exam. So you'll be somewhere around here. Okay? Anything else? A specific question. I'll get that in a minute. Any other? Y'all good with that? All right. So we'll be done in just a second. What time is it?
2:54.
Man, I did pretty good. Wow. You could tell I've been out for a while.